A very good way to determine the cost to maintain a building envelope is with a 3D model. This is a model of a 4-story office building, and it's made up of drawing layers, each of which is dedicated to a component of the building envelope. Here's a layer for the soffits, and here is the layer for the brick panels. Here's all the precast concrete surfaces, and here's all the glass. There's layers in this drawing for all the sealant joints also. There's the joints between the brick panels. Here's the joints between all the precast building elements. And there are 2 layers for the window and door frame perimeter joints. And there's others. With this model, cost analysis for virtually any purpose is benefited. This building was due for sealant restoration, and the model was created to determine those costs. Because if you know the average cost per lineal foot to install the joints, the model makes determination of the total cost pretty straightforward. I'll show you how it's done. First, you turn all the layers off but the ones that carry one work element. So this particular work element is all the window and door frame perimeter joints. And then if I select them all, I can see that there's 7,592 lineal feet of that kind of joint. The cost to restore those joints is that number times the unit cost of between $4 and $5 per foot. So it would cost about $38,000 to replace all the perimeter joints on this building. And then I would just repeat that exercise for all the various kinds of joints. Here's the precast joints, of which there's 2,721 lineal feet. And then I would look at the all the surface area. There's 32,150 square feet of precast panels on this building. So I would do that through every different category of work in the building envelope, and the total would tell me what it would cost to restore all that on this building. Of course, restoring everything at the same time may not be practical. Let's say that the current budget is less than what it would take to restore all the joints and surfaces, but there's leaks in some of the windows on this wall, the one that faces the prevailing weather. To see what the replacement of joints on that wall alone would cost, you do the same thing that was done before, but do it on that wall only. So I've set up a couple of scenes to help me isolate that wall and to readily pick just the elements that I care about. So here are the layer that's on right now are those perimeter joints. And if I just select all those elements on that wall, I find that there's 1,407 lineal feet of that particular joint on that wall. Now, it'd be pretty inefficient to repair just those joints. If you're going to mobilize a crew and rig the building, you'd want to take advantage of that and work on all the joints. So I could just repeat this exercise with the precast joints. I could do the same thing with the surface area and so on, and then I could add that all up and figure out what it would cost just to do that one wall. So the model has a lot of utility. I mean, there's a great deal that can be done with this once it's created, and it lasts for the life of the building. Every project you do will benefit from having all this information at your fingertips. And if the owner knows all this about the building, he'll know what his expenses will be for the envelope maintenance, and he'll know the quotes he's getting from contractors are reasonable for every service is needed, which will give him a strong negotiating position.